Hello grade 7 students, welcome to another video session. Our topic for this video is all about significant digits, and this includes rules for significant digits, rounding numbers applying significant digits, adding and subtracting with significant figures, and multiplying and dividing with significant figures. It is fair to say that significant figure is the most hated topic of the students, yet this is the most important concept applied in chemistry and other related sciences. So it is really important to know the idea and concept about significant figures. On the other hand, significant figures and significant digits are just the same. Sometimes, sig fig rules is written instead of significant figure rules or significant digit rules. So these are the rules to follow to determine how many significant digits a number has. First, all non-zero digits are significant. Non-zero digits pertains to digits from 1 to 9. So if ever you will see these numbers or digits, these are counted as significant. Example, we have 45.91. 4 is a non-zero digit, 5 is also a non-zero digit, as well as 9 and 1. Therefore, there are 4 significant digits in 45.91. Second, all zeros between non-zero digits are significant, or in vernacular way, tanang zero nga natung-an og dili zero nga digits kay significant. Example, we have 203. So in this number, there are 2 non-zero digits, 2 and 3. And there is also a 0 in between non-zero digits. So naay 0 tunga ni 2 og 3. So 0 will be counted as significant kay napatungan man siya ni 2 o ni 3, which are non-zero digits. So in 203, there are 3 significant digits. Next rule, we have trailing zeros are significant if there is a decimal point, while not significant if there is no decimal point. By the way, trailing zeros are a sequence of 0 in the decimal representation of a number. For example, we have 23,000. So in this number, there are trailing zeros, but it does not have a decimal point. So therefore, the trailing zeros here are not significant. So only digits 2 and 3 can be counted as significant. So there are 2 significant digits in 23,000. Another example, we have 89.30000. So in this example, it has trailing zeros and a decimal point. So these trailing zeros here can be counted as significant. So mahimo siyang significant, makount siya as significant digits. Kaya naaman siya decimal point. So there are 7 significant digits in 89.30000. Fourth rule is that if a 0 and only a 0 comes before a decimal point, it is not significant. Or in other words, leading zeros are not significant. Say for example, we have 0.0056. So as we can notice, there are zeros that came before the decimal point. So these zeros can be considered as leading zeros. And take note that leading zeros are not significant. So for this example, only digits 5 and 6 are significant. So there are 2 significant digits for 0.0056. Okay, down to the fifth rule, all zeros after a non-zero digit and after a decimal point are significant. Okay, say for example, we have 90. So the 0 came after a non-zero digit. So the 0 there can be counted as significant. So there are two significant digits for 90. Okay, another example we have 1.6000. So the zeros came after a decimal point. So take note that when a zeros came after decimal point, those zeros can be considered as significant. So in this example, there are 5 significant digits. So always remember the rules for significant figures in determining the number of significant digits each number has. So moving on with our next topic, which is all about rounding numbers applying significant digits, we will recall first the rules for rounding off. So to round off numbers, look at the digit immediately to the right of the one you want to round off. If that digit is less than 5, leave the number unchanged and drop all the digits after this number. If the digit is 5 or greater than, add 1 to the number to round off. Now, to round off numbers to the number of indicated significant digits, let us have an example. Okay, say for example we have 67.795 into two significant digits. So remember that 67.795 has 5 significant digits. So all we have to do is to round the given number in such a way that the rounded one will result to 2 significant digits. So how is that so? First, we will identify 2 digits of the given number from the left, so the digits are 6 and 7. Next is to look at the digit at the right of 7. So that digit is 7 also. Now, take note that 7 is greater than 5. So we are going to add 1 to the number to round off. So 67 plus 1 is 68. Now the answer, 67.795, round to 2 significant digits, the answer is 68. Next is when adding and subtracting with significant figures. Now, when adding or subtracting with significant figures, the answer can have no more places after the decimal point than the least of the measured numbers. Okay, example we have 13.0198 plus 1.2. First is to add the two numbers and the result is 14.2198. But take note that our final answer should be in the correct number of significant digits. So the 14.2198 is not our final answer. So what we are going to do is to identify the number of decimal places each addend has. So, itong identify og pila ka decimal places ang naa sa 13.0198 og 1.2. So for 13.0198, there are 4 decimal places. Then for 1.2, we have 1 decimal place. So that means that the final answer could only have 1 decimal place. So our final answer is 14.2. Okay, next example we have 789.04 minus 45.978. So the same thing, we have to identify the number of decimal places. So for 789.04, there are 2 decimal places, while for 45.978, there are 3 decimal places. If you're going to subtract the two numbers, the result is 743.062. Now take note that the answer can have no more places after the decimal point than the least of the measured numbers. So the least number of decimal places is 2. So our final answer should have 2 decimal places. So our final answer is 743.06. Okay, down to the last topic about significant digits is all about multiplying and dividing with significant figures. So when multiplying or dividing, the result can have no more significant figures than the least reliable measurement, or the number with the fewest significant digits. So unlike in addition and subtraction, we are going to determine the fewest decimal places. In here, we are going to identify the fewest significant digits. For example, we have 1.5 times 2.03. First, we are going to identify the number of significant digits of our multiplicand and multiplier. So for 1.5, there are two significant digits because the two digits are considered to be significant. Next, for 2.03, there are three significant digits. The same thing, we're going to multiply the two numbers. The result is 1.545, and it should have two significant digits in the final answer since ang kinagamian is two significant digits. So for this example, the final answer is 1.5. Okay, next example, we have 4.90 divided by 8. So the same thing, we are going to identify the number of significant digits each number has. So for 4.90, there are two significant digits because 0 there is not significant based on rule number 5. And for 8, there is only one significant digit. So if we are going to divide 4.90 divided by 8, the result is 0.6125, and it should have one significant digit, and our final answer should be 0.6.